this video, we will tackle about identities, racial, Pythagorean, reciprocal, and lastly, double angle. Let's start.
For our first problem, we are going to use ratio identities of cotangent theta equals cos theta over sin theta, and tangent theta equals sin theta over cos theta. For our first given, we have sin x times cot x plus cos x tan x squared plus cos x plus sin squared x. Now let's start working on the left side of the equation. First, rewrite the terms inside the second parenthesis by using the quotient identities. Open and close parenthesis sin x times cos x over sin x plus cos x multiplied by sin x over cos x. After that, find a term that can be cancelled out. So as you can see, cos x can be cancelled out here. After you find the term that can be cancelled out, add number 1 as the denominator of the sin x because it will still remain as sin x, so that you can multiply it by 1 to get a common numerator and denominators. After that, add the common numerator and use the same denominator that is used in the two fractions. Now, you can simply cancel the denominator, which is the sin x in the outer. When the remaining terms on the left side has the same as the right side, then you've successfully proven the identity.
In this number, we can use the first Pythagorean identity, which is cos squared x plus sin squared x equals to 1. So the given is cos to the fourth power x minus sin to the fourth power x is equal to cos squared x minus sin squared x. So first, focus on the left side and get the difference of two squares, which is cos squared x minus sin squared x times cos squared x plus sin squared x, which is equal to 1. It will be now squared x minus sin squared x times 1. After that, multiply them, and after you multiply them, you have now proven the given, since the answer cos squared x minus sin squared x is equal to the right side, which is also cos squared x minus sin squared x.
In this number, we can use the reciprocal identity, which is secant theta is equal to 1 over cos theta. The given is secant theta over sin theta plus 1 equals 1 minus sin theta over cos squared theta. First, focus on the left side. It will now be secant theta over 1 plus sin theta times 1 minus sin theta over 1 minus sin theta. Multiply secant theta to 1 and negative sin theta, and multiply the denominators also. It will now be secant theta minus secant theta sin theta over 1 minus sin squared theta. Get the reciprocal identity of secant, which is 1 over cos theta, then subtract it with 1 minus cos theta times sin theta all over cos squared theta. It will now be 1 over cos theta minus sin theta over cos theta all over cos squared theta. Divide the equation. It will now be 1 minus sin theta over cos squared theta times 1 over cos squared theta. The final answer will be 1 minus sin theta over cos cubed theta. We verified it since it is equal to 1 minus sin theta over cos cubed theta.
Solve this number. We can use the double angle identity. Which is cos 2 theta is equal to 2 cos squared x minus 1. So our given is 4 cos squared x plus cos 2x is equals to 5 minus 6 sin squared x. So to prove it, focus on the left side. Substitute the number 2 in the cos x to make it 2 cos squared x minus 1 or that is 4 cos squared theta x plus 2 cos squared theta x minus 1. After that, add the 2 cos squared x to make it 6 squared x minus 1. Substitute cos squared x into its Pythagorean theorem to make it 1 minus sin squared x, or 6 times 1 minus sin squared x minus 1. After that, multiply 6 into 1 minus sin squared x to make it 6 minus 6 sin squared x minus 1. Then move negative 1 on the left side to make it 6 minus 1 minus 6 sin squared x. And simply subtract to make it 5 minus sin 6 squared x. Then we have verified it since it has the same answer to the right side, which is 5 minus 6 sin squared x.